All right, so CSE 223. I'm not going to spend a lot of time talking about administrative background and such, but I want to run through a few things really quickly on Canvas here. So the first is the be sure to read thing, which most of you have probably already read, but just to reiterate, right, this is not an online class in the usual sense of an online class where you just show up whenever you want and do the assignments at your own pace. It's a basically face-to-face class, except face-to-face is through Zoom. But we meet every day at this time, 2 o'clock to 2:50, or 10 to 10:50 for the earlier section. And so you want to come to every class, okay, and participate. I'm not committing to posting videos on YouTube, but I'm going to try. I don't know how much bandwidth I have from home, but I'm going to try to post the videos for this class for at least one of the sections each day. We're meeting through Zoom. Since you're here, you already know that. But if this code changes, I'll announce it through Canvas, okay? Why would it change? If, for example, people are coming into class who aren't supposed to be in here, then I may change the code and release it through Canvas, and then only people who are in this class would be able to come in. You'll see notes on Clark's website saying there's no final exam week. We will have a final exam for this course. Okay, it'll be on that last Monday, June 15th, and I'm only allowed to do 50 minutes worth of final exam, so if we want a 2-hour exam, it'll stretch out for 2 days. I haven't decided if that's happening or not. The other thing to note is that you do not get 2 weeks for each programming assignment, okay? The first assignment in particular is due a week from tomorrow, and there's an earlier assignment which is due on Wednesday, 2 days from today. So it's a tighter schedule. Make sure you pay attention to due dates, and if any questions ever come up, shoot me an email, right? You should all have my email if you were in classes with me before. If not, the email is down here. You can always shoot me a note and we can go from there. So this is an online presentation, right? We're using Zoom. Zoom is, to me, still pretty experimental. I'm still figuring out some of the details. And so we'll work with it, and we'll make the technology work as best we can. But if you have any questions or issues, again, best bet is to email me. I'm actually keeping my phone turned on during lecture with noises. And if something comes up, you're getting disconnected or you can't get in or something, shoot me an email, okay? And we can try to resolve it at the time. You don't have to wait till after class or whatever. So I also posted a page on student resources, and I want to make sure people are aware of this. Student Support Services at Clark does a fantastic job with offering assistance to students, whether that assistance is in the form of financial help, and I'm not talking about financial aid. I'm talking about, I have a job interview next week and I don't have appropriate work clothes to wear to it, and I don't have enough money to go out and buy them. What can I do? Talk to Student Services, okay? They have resources available to help students with situations like that. If you're having housing difficulties, if you can't make rent and you're not sure what to do about it, if you're having food difficulties, right? The Nerd Cave is closed up right now. A lot of people were going there to, get something to eat during the day, and people depend on that, right? So if you're having issues with that, there's a food pantry available. Talk to Student Services. So Cash Bushra is your main contact. You can shoot them email here, or touch base with me if you've got a situation going on, and we can brainstorm, try to figure out creative solutions to whatever is going on. As we're going through Zoom, if you want to get my attention, you can try raising your hand. I think I get notifications about that, and I'll stop talking and I'll ask if someone has a question. But worst case, just turn on your microphone and start talking, and I will probably notice. I think my sound system is solid at this point. Syllabus pretty much looks the same as it always has. The only modification I really made was putting this note up here about this being a class that meets at regular times and dates. which I think everybody gets at this point. I'll let you read through the syllabus on your own, okay? But you can download the textbook for the course from here. It's an open access book. It's free. You can read the course outcomes. The grading is on here. I'm not planning on doing one-day projects this quarter, so the grading is 5 categories. Programming assignments, 30%. Some online Canvas quizzes, which I'll open in a few days, that's 10%. Service learning project is 10%, that's still going on. And then midterm and final, total of 50%, 20 and 30. That's your grade computation for the course. Course policies, support services, accommodations, college-wide policies. You've heard me read through these before. If you've had classes with me, if not, please read through these and make sure you understand them. But again, I'm not going to take class time this quarter to do that because we're on a very tight schedule. And we probably won't cancel because of bad weather, but you know, who knows. Additional course policies, again, this is sort of boilerplate. It's the same stuff we've had before, but we're meeting through Zoom. There's the meeting times and dates. engrcs.com/schedule lists my available office hours, okay? Generally, it's 8 o'clock in the morning, daily, Wednesdays at 7, I believe. And Tuesday, Thursday, I have hours for my Engineering 250 class, okay? So you can find me there also. There is a Discord channel for the course. This is not an official Discord for the course, meaning I am not monitoring it, I'm not policing it. But it's a resource students can use to talk to one another, to kick around ideas, or, you know, I didn't understand when this assignment is due. Is it due, you know, on that date or this date, right? Things like that. I hop on there sometimes, and if you mention me in a message, I should find it. But, you know, email is the guaranteed most direct, most certain way to reach me. But sometimes you can catch me on Discord too. And I'll let you read about my course policies. But again, if you've had me in other courses, none of that has changed. All right. Unless there's questions, let's go ahead and jump into some programming. And let's start with programming assignment A. So this is a warm-up. This is a hello world for Java. So let me talk about this, and then we'll talk about what Java means in general. But this is basically a 10-point warm-up assignment, so it's a hello world. Your goal in doing this is to do the following. First of all, you need to make a file called pa0.java. Now, you can do this code on the server, okay? Or if you have a Linux environment at home, you can definitely do it in Linux. If you have a Mac, you can do it in OS X. If you have Windows, you could open a DOS shell and probably do this if you download the Java development kit. But easiest course for now, just go ahead and do it on the Linux server. And for the first few assignments, everything we do will work fine on the Linux server. So what are you going to do? You're going to make a file called pa0.java. You're going to put this code into it. You're going to compile it with this command, and you're going to execute it with this command. And when you do all of that, you should have a program that just printed out hello world. Okay? And then you're going to submit the source code, which is pa0.java. You're going to submit it through Git. And again, if you had 222 with me, you know the drill. You're going to make a repository. It has to be called exactly CSE 223 PA0 uppercase. And then you're going to push your project over to GitLab, not GitHub, right? Under that repository name. And then you're going to add me, Nick Macias, at Nick Macias as a reporter. Okay, and that should be all set up. That should get everything that you need to do to get your 10 points for PAA. If you are not sure about how to do this, or if you've forgotten, or if you haven't had 222 with me, right, do this today and send me an email today and say, hey, I think I pushed this over. Can you check and make sure that you can access it? Okay, or if you can't get it pushed over, send me an email and we'll talk through it. Okay, this is really, it's a hello world. It's your first program in Java, but it's also to make sure that you can submit your other programming assignments correctly. Okay, because they've got to be submitted on time correctly in order for me to download them and grade them. So let's run through this process really quickly. So let's make pa0.java. I think it's going to go crazy on typos. It's typo o'clock right now. Now, it's going to be a few weeks before we actually understand what all of this means, okay? But it's just going to be a mantra. Anytime you want to write a program, you're going to have something that says public static void main parentheses string bracket bracket r close paren, curly bracket. And the body of your code is going to go in between these two curly brackets. We're going to do this again and again and again. And we don't need to understand what all of this means to be able to write this code and compile it and execute it. But starting tomorrow, we will begin understanding what this public class means and so on and so forth. Public static void main will take probably a couple of weeks before we really get into it. But for PA0, all we need is to type this code in. Okay, so we'll save that. And we compile it by saying javac, that means Java compiler, and the name of the file, and it's got to be the full name, pa0.java. So we compile it, and then to execute it, we just say java pa0, and it runs and it says hello world. And I didn't type in the code exactly like I had it in the assignment. We don't need this \n at the end, because print line puts in a hello world, new line at the end. All right, so put it under git control, right? Do a git init, do a git add, git commit, do a git remote add origin, git at gitlab.com, username /cse223 pa0.git, git push origin master. It's all in the slides. It's all stuff you've done before. If you're not sure how to do it, send me an email, and we'll work through the details. Do that, and that's the end of PA project A. Okay, so let's talk about Java. Let's talk about what this course is really about. So this is CSE 223. It's a sequel to 222. 222 was data structures in C. 223 is two things. It's advanced data structures. So we go a little further with some of these things. But it's also done in Java. And it's an object-oriented language. So it's really learning about object-oriented programming. So what is an object? What do we mean by object-oriented? Let's think about C. So in C, we say something like integer I, or we might say character C, or we might say char star S for a string. And so on. We have different types of variables, okay? Now these things here, I, C, and S, these are variables. These things, int, char star, these are types of variables. Okay, that's C. We know that. In Java, these things are going, so this is C. In Java, these things are going to be called objects. So objects are going to be like variables. They're going to be things that hold information. And these types of variables are going to be basically things that we call classes. So I is a variable of type int. We're going to here say I is an object of the class, int or something else. So classes are basically types of variables, and objects are basically variables themselves, or if we like, instances of these types of variables. Okay, so why is it an object instead of a variable? A variable is a piece of data, okay? And it could be an integer, it could be a character, or, you know, if we're in C and we like structures, we could have a structure called a linked list, and it has, you know, an integer data, and it has, you know, some other stuff to it. And we could say, here's a node whose type is struct list, and we could say node dot data equals 17. And so node is not an int or a char, it's a more complex variable. It's a variable of type struct list, right? And it has fields associated with it, and one of those fields is called data. So if we have node as our struct list, we can say node.data and access that field. Okay, so we know that we've been doing that, you know, for the better part of a year now. Okay, here's what happens with objects. An object is, you know, a variable that has all these different fields associated with it. It's part of a class. A class is a type of variable with all these different pieces of data in it, but it can also have code inside it. So a class describes not just the pieces of data that are contained in an object, but also the set of code that you use to interact with that data. Okay, this is the key concept. So for example, in C, we might have an integer called I, and a character called C, and a string called S. And we might, you know, say something like I equals absolute value of I. Or we might say, let's take C and turn it into an uppercase character. Or we might say, let's take the length of this string S. This function string length is not inherently associated with this variable S. We just kind of know, since S is a string, we want its length, we'll call the string length function. If we tried to call toUpper on S, we'll probably segfault. toUpper expects a character. If we want to turn S into an uppercase string, we make a loop, right? And we go through character by character, and we change each character into an uppercase one by calling toUpper, and we put those back together into a string. If we have an integer and we want its absolute value, we can call absolute value of that integer. We could call absolute value of a character, and it would do something, but probably not what we expect. We don't really need the absolute value function to exist if we're only dealing with a character or a string. So in C, you kind of have functions over here, you have data over there, and they're just sort of two separate collections of things. Okay, in Java, we put these together. And every piece of data, every object has associated with it all the functions that we use to interact with that piece of data. So they're bound together. Okay, and this is really powerful. When I make a linked list, part of that linked list is going to include the code for traversing it, for inserting something, for counting how many things are in that list, and so on and so forth. Okay, this is what object-oriented design is about. So let's just play with some code. I'm going to make a class called fun. And most of our code is going to start with a public static void main if it's got a main program to it. Hold on, I'm checking emails to make sure somebody's not locked out of class. Okay, we're good. So let's make a function. So let's make integer I and j, I equals 10. Let's make a function called twice. Which multiplies its argument by 2. Okay, so how do I make a function? Don't worry about the word public for now. Don't worry about the word static. In general, we're not going to use static down here, but since I don't want to go into a lot of complicated explanation right now, I'm just going to use the word public static up front here. Okay, but we'll talk about that later. But we're going to write this like we write C. We're going to say integer because we want our function to return an integer. I'm going to say twice, which is the name of the function, and I'm going to specify the arguments. So I'm just going to call it arg. I'm going to say return 2 times arg. There's my function. Looks a lot like a C function. Other than this public static business up here, right? This could be C. This could be C. Okay? You can write C in Java. When I first tried to learn Java, I ended up just writing a lot of C code in Java. Don't do that. Okay? We want to write Java code in Java. That's what this quarter is about. But everything that you know about writing C code will help you in writing Java, because the structure of functions, while loops, for loops, if statements, putting semicolons at the end, the way that you write comments, all of that stuff is exactly the same as it is in C. But it's better. All right, so here's my function. Takes an argument, multiplies it by 2, and returns that value, and that becomes the value of j. Let's look at the result. Okay, this is a little easier than it was in C. I want to print out the message, the value of j is, and then I want to follow it by the value of j. Well, this plus sign, this concatenation operator, is really powerful. Okay, it says take this string and append to it this string. Well, j is not a string, j is an int, right? But it knows how to convert j into a string. So j gets turned into a string, appended to the end of this string, and this should just print out the message the value of j is, and it should say 20, because that's twice 10. Okay, so we don't have to mess with %ds and all that kind of stuff. So we'll compile this, and it's case sensitive. And then we'll run it, and it says the value of j is 20. And not surprisingly, you know, if I set j equal to -17 and I run this, the value of j is -34. So no surprises there, right? Functions basically work the way that we're used to them working, with a few nuances that we'll be talking about as we continue. All right. And again, if there's questions or comments, just throw up your hand or just turn on your mic and start talking. Because honestly, if my Zoom session like timed out, I could just be talking to myself and I wouldn't know. But I am recording. All right, so what is this Java C Java business? Fun.java is the program that we wrote, right? That's the human readable version of our program. When we compile it, when we say Java C, what we get is this program called, this file called fun.class. And if we look at that, it's not human readable. Okay, it's binary code. But it's not binary code that can be executed by the Linux operating system. If I make this thing runnable and I try to execute it, right, I get this cannot execute binary file exec format error. Okay, so what is fun.class? What is this binary file? Well, it's file for a imaginary machine. It's the ones and zeros, the machine code of a machine that doesn't actually exist. It's a machine called the Java Virtual Machine, or the JVM. So when we want to execute a compiled Java program, this fun.class, we have to first create this virtual Java machine, and then have that virtual machine start interpreting the ones and zeros in this .class file. Okay? That's what the Java command does. Java starts a Java virtual machine, and Java fun says feed that virtual machine the binary file fun.class, and it causes it to execute, and there's the value of, there's the output from your program. So Java is compiled, but it's also interpreted. It's compiled in that we run the javac command to change it from human readable form to machine readable form, but then it's interpreted because that machine readable form, the class file, does not directly execute on an x86 machine or an ARM machine or a PIC processor or any other piece of hardware. It runs in this virtual machine called the Java Virtual Machine, the JVM. So that's a performance hit, but it's not too bad. The JVM is pretty efficient, and CPUs are pretty fast anyway. If you want absolute fastest speed, you probably don't want to use Java. But for most of what we're doing, speed's not our primary goal. It's transportability, maintainability, efficiency, things like that. Efficiency of development. All right, so let's look at classes. So I'm going to make a string called S. And I'll make my string S equal to, this is a test. And I'll print out the value of S is, and I'll just concatenate an S to it. So I can compile that and I can run it, and it tells me the value of S is, this is a test. And remember this trick that I mentioned in 224, suppose my string has spaces at the end. Well, when I run my program, it tells me the value of S is, this is a test, right? I don't know that there's spaces there at the end, right? So anytime that you're printing stuff, strings in particular, I like to put it inside delimiters. So here I'm printing out the value of S is angle bracket, and then I'm concatenating the string S, and then I'm concatenating a new string, which is just a closing angle bracket. And if I do that, and I compile it and I run it, now I can see really easily my S actually contains a bunch of spaces at the end. Okay, so that's a useful debugging trick in general, but also as an example of, the power of this concatenation. Okay, now suppose we want to know how many characters are in the string S. Suppose we want to know how many characters are in here. C we would call a string length function. We would pass it S as an argument, and the return would be an integer telling us how many characters are in there. It works differently with objects. So S is an object of type string, right? An object of the class string. The string class includes a method, a function called length. So, with a linked list, we could say node.data. With a string, we can say s dot, and this could be the name of a field in that variable, but it can also be the name of a function, in this case, a function named length. So it looks like we're accessing a field in a structure in C, right? What we're really doing is invoking a method, okay? Functions in Java are called methods. We're invoking a method that's part of this object, S, which is an object of type string. Okay, so S says this is a test. S.length says call the length function or method on this string and return the result, which would be the number of characters, and this is a length. And now we're going to print that out, concatenated in the message, the length of S is. Go ahead and run that. The length of S is 14. If I want to convert this string to uppercase, there's a method for that. It's called toUppercase. So I can say s.toUppercase, that will run the toUppercase method on S, and return its result. So I can run this, and uppercase S is shouting this is a test. Right, or I could have done this. I could have said S2 equals S dot 2 uppercase. And then I could concatenate S2 to my text string. And it does exactly the same thing, unless you make typos. All right, so what's going on here, right? We have variables, which we call objects, which are variables of type something, which we call a class. But as soon as we do that, we suddenly have the ability to call functions that are associated with that class, like toUpperCase or length, right? And in some sense, we can think of them as being part of this variable S, this object S. And we don't actually get multiple copies of the code every time we make a new variable of type string, but the effect is, yeah, length is just, part of this object. toUpperCase is just part of this object. And there's links on Canvas to the documentation pages for Java, and if we look at those pages, we'll see, for example, class string, and there's information in the front about what a string is and some examples of how to use it and so on. But if we come down here to the method summary, here's all the functions we can use associated with a string. If we want to know the character at position 5, we can say string.character at 5, and it'll give us the character at position 5, which is the 6th character of the string. If we want to compare two strings, we can say string1.compare2 parentheses string 2. And it'll compare those two strings alphabetically, and it'll return something that's 0, positive, or negative. It's string compare, right? If we want to concatenate two strings, we can use the plus sign, or we can call the concat function. Or we can see if two strings are equal by calling equals. And we can find the location of one string and another by saying index of. So every class comes with a whole bunch of methods. If you like regular expressions, we can see if a string matches a regular expression by saying matches and just give it a regular expression. And all of the stuff is hyperlinked, so we can click through and get more detail about what these methods do, examples of how you use them, the possible things that can go wrong, other things to look at, and so on and so forth. So you'll want to spend a lot of time looking at the manual pages. Yeah, Raj, you got a question?
Yeah, I was wondering if you do like the concatenate S2, and then inside of that, could you use that have it equal to toUpper?
Yeah, so these things go together nicely. So S2 equals S1 dot concatenate, or S dot concatenate S dot toUpper.
Okay. And you can also do it in the print statement as well.
And you can do it in the print statement as well, yeah.
That's pretty cool.
So this is a nice thing about Java, right? To me, at least, most anything that makes sense ends up working in Java. Okay, that's a pretty controversial statement, but it's just based on my experience, right? If I would like something to work a certain way, I can try it, and chances are it does work that way. So definitely do these kinds of experiments, right? And if you find something that's not making any sense, let me know. But surprisingly, most things that I've tried to do actually work the way that I would like them to work. So it's a pretty fun experience in that sense. All right, so we have these classes like strings, right? And tons of documentation available on them. And they come with methods we can call to manipulate the data or investigate the data. And that's pretty cool. The other nice thing about working with objects is it lets us build on things that have already been figured out, either by ourselves or by others. Okay, somebody created the string class and these two upper methods and the length method and that kind of stuff, and now when we want to work with strings, we don't have to reinvent the wheel. If we want to convert a string to uppercase, we don't have to make a for loop and include ctype.h and all this sort of stuff, right? We just use the to uppercase method. So let me give you some examples of where this gives us some cool opportunities. So here's a file called GUI.java. It's 9 lines, okay? It's got an import statement. This is kind of like a number sign include in C, but it works totally differently. It's not pulling in source code like pound include, but it's basically saying we're going to use classes from this class library, okay, javax.swing. So here's my line that I always put in the beginning of my program, and we haven't said why. Here's my public static void main that we haven't explained, my opening curly bracket, my ending curly bracket, my last ending curly bracket. This is really 3 lines of code that I've written, okay? The first one says JFrame. That's the name of a class, okay? It's a class from this swing package. So this is like saying integer JF, but instead of int or node, I'm creating an object of type JFrame, okay? So JFrame JF. And new is a keyword, okay? New basically takes the place of malloc. So when we created linked list and we wanted to make a node, we had to say, struct node root equals, or struct node root equals malloc size of struct node, right? That's basically what new is doing for us. It's saying I want to actually create an object of type JFrame. That's what the new keyword tells it, okay? But there's a whole lot more we can do. But this is basically declaring a variable to be an object of type JFrame and then doing what we call constructing it or instantiating it, actually creating space and memory for it, okay? And then I run 2 methods associated with that JFrame object. The first one says set default close operation. This says that the thing that I'm going to create, when it goes away, my program should exit. And then this one says make it visible, because normally when I create a JFrame you can't see it. So I really have 3 lines of code here, and let me show you what this does. And you gotta watch really closely. You ready? Alright. So what just happened, there's a tiny little thing up here on the upper left which I can drag over. That's a window. Okay? I can make it bigger because I'm good with my mouse. It's a whole little GUI window. It doesn't have anything in it, but I can maximize it and I can demaximize it and I can make it go away and I can bring it back, and I can exit to close it, and when I close it out my program exits. Okay, so 3 lines of code, we get a pop-up window like that. Here's a similar one, GUI 2. I've added 1 more line of code which says set the size. Right, so JF is the object which is my window, and it has a method called set size, and I'm setting the size to be 800 across, 400 up and down. And so now when I run this, I get a window that's already got some reasonable dimensions to it. Alright, GUI 3, GUI 4, GUI 5, GUI 6 are all going to look exactly the same, except instead of creating a new JFrame to make an object of type JFrame, I'm creating something of type myFrame. Okay, what is myFrame? myFrame is my own version of a JFrame. It's something that I wrote. And when I run it, I get a frame, but it's got a little circle in the corner. Now, how much code did I have to write to create something that looks like this and has a little icon in the corner and lets me resize it and lets me maximize it and demaximize it and close it? Very little code. So let me show you what a myframe is. Right? It's basically 2 lines of code. There's boilerplate stuff up here, more includes. This is the definition of a myframe, but I said it extends a J-frame. So I'm not reinventing all the stuff that makes that frame that we can drag around and resize and so on. I'm saying I want to start with that, but I want to add some more stuff to it. Okay? So I started with a J-frame, I created an extension of it called myframe, and in that extension I added basically 1 line of code which said draw a circle, an oval, at 77 with radius 50-50. And when I run that, now I get a J-frame with a circle in the middle. So code reuse is a key part of object-oriented design. And we can have these objects that have all this capability built in, and we can extend them and just add new pieces to them. So really good support for code reuse. All right, here's a myframe 4. It's got a for loop inside, which basically runs x from 0 to 800, calculates the sine of x over 50, and then draws a little tiny rectangle, a 2x2 filled in rectangle located at x, comma, 200 plus the sine of x over 50. Okay, without worrying too much about why we're doing that, let's just see what it does. It draws a sine wave. Right? So, a few lines of Java code, and we've got this kind of thing happening. Here's myframe 5. Well, this one, instead of drawing a rectangle at xy, I'm drawing a line from the origin, the upper left corner, to xy. And when I run that, I get a kind of cooler looking sine wave. And, you know, it doesn't care how big the window is. If the window is really small, it fills it up. If the window is really big, there's empty space here. Suppose that I wanted to make this responsive to the size of the window. It really takes almost no more work. Basically, instead of going up to 800, I go up to something called getWidth. And getWidth is a method available inside a J-frame, which means it's available inside a myframe, and it tells me how big the window is across. And getHeight tells me how high the window is. And so by just changing my code to use getHeight and getWidth, I can run GUI 6 and have a window that's responsive to how big the frame is. Okay, so I offer those just kind of as motivation for this idea that objects are cool, right? Having this object-oriented mindset takes a little bit of getting used to, but is really worth it. Because the things that we start working with and start building are going to be so generally useful. We're going to build on things that already exist, and we're going to create things that can be extended and built on top of that. And so all the modular design that I've been preaching since 2.24 really finds a natural expression in an object-oriented paradigm like Java. So that's going to be something good to look forward to. All right. So tomorrow I want to start digging into more of the details about what some of these things mean when we say public class such and such, and the placement of these curly brackets and that kind of stuff. I want to actually start looking at doing some programming in Java. Programming assignment 1 is posted. It's due a week from tomorrow. We will start talking tomorrow about the things you need to know to do that assignment, and we should get through that in a day or two. And that should leave you plenty of time to get PA1 done and working. But make sure you do PA0 or PAA today if possible. If you're having trouble, if you're unsure if it works, shoot me an email and I'll check it for you. Get that in and get it taken care of. Then you don't have to worry about Git setup and stuff for the rest of the quarter. All right, we've got about a minute left, so if there's any questions, go ahead and chime in. Otherwise, have a good rest of your day, and I will see you tomorrow.